And then there is a hydrology, water runs down the hill. And then there is a lithosphere, what happens in the soil, and our resources and fossil fuels and all that, because we might actually make trade-offs. We might get less, we are making trade-offs. We cut forests to pump up oil and that kind of stuff. And then there is an atmosphere. So all these things happen, and then also in that cell there is an anthroposphere, and the anthroposphere is defined by a social capital that is like who knows who, how close are we together, and that social capital that forms a culture, and within that culture we have human capital that how we as a culture know how to do actually drives our economy, and then the economy has the needs for the ecosystem services. So all these things happen at the same time. So in this model, I'm then actually able to calculate the trade-offs between all the different interest groups and show whether trade-offs work or don't work in a spatial temporal scale. They might work for now, but 100 years from now, they might actually. And then I can run like global climate change scenarios through it. What about if we have a lot of people coming? So there are a lot of what-if questions that you can play, and where do we end up? So that's the kind of work I do. The assumptions within the MIMES. Ecosystems are the structures and processes that generate functions. Next one. Ecosystem functions are the values of human beings, the ecosystems. That was a whole big one. The characteristics of the ecosystem services is that the structures are not transformed into the produce services. A lot of people think that lumber is the ecosystem service. I'm like, no, lumber is not. Lumber is the service of a forestry industry. Growing the trees is the ecosystem service. And the value of the lumber is partly growing the tree, partly what humans do, partly. So it's like there's a... and then also, ecosystem services tend to be fueled by solar energy. That's why I think ecosystem services are the best distributed services on the planet, because everybody can make use of solar energy. Sun shines everywhere. And my mom said, like, the sun shines for free. The alternative to the sun is fossil fuels. So as the ecosystem services have been failing, we have been substituting it with fossil fuel substitutions. And that's why the price, we were losing them, but since we have the substitutions, we haven't had that price signal of things getting really expensive. And now we kind of start running out of fossil fuel, or at least we don't pump it up as quick. All of a sudden, everybody starts feeling the scarcity in ecosystem services. It's like, I was heating my house with oil, maybe I should go into heating it with wood. Well, if everybody starts using wood, so there's all of a sudden demand for these things start coming up. And then, the availability of the ecosystem services don't necessarily work in our plants. I mean, the ecosystems have their own plants, and we don't necessarily understand how they are produced. They're so complex. They're all there. So anyway, those are the kind of typical things of ecosystem services. Development, what we need for the valuations. Basically, and I said that it's like we would like to look at the trade-offs and scenarios. When people make decisions, we want to know who is losing what versus others who are gaining what. And there is this idea of setting up like markets, that people who are losing will compensate people who are gaining. And maybe that can be part of the discussion later on. But anyway, we work. And so then a lot of the methodologies that deal with getting these values is called benefit transfer. So people are asked, like, what is it willing to pay? What are you willing to pay? And then other studies somewhere else say, well, those people there in Canada said this, so it's probably something like this here. And so that's a lot of how things are done. That doesn't really work very well simulation models, because and in scenarios, because I think values actually, you know, the prices and the values actually change with the scarcities of the goods. So the prices themselves are flexible. So we need to get a better methodology on how to define these prices, and also so we can run them into future scenarios where we don't have any data yet. And so that is where we come up with the marginal cost pricing system. Also, the MIMES is a deductive approach, which is like we start with the story. This is important to us, that is important to us. This is how we think everything works together. Now let's check with the data and see if that is really true. Other people start with an inductive approach. They say, like, here is all the data, let's see what the data tells us for a story. Why the deductive approach? We can actually involve all the stakeholders. We can talk to everybody, ask all the stories. Recognizes that the economy is a human construct, human values, so we need to know about these human values. It's like the model itself is totally unimportant. What is really important is that we learn from each other and have this as a, some people call these models our doll to play with. So it's like the doll is not important, but the process you go through. You know, and it can provide for consensus building, so that means like we're buying into the system, and we allow for scenario building. So I think, these are the companies I work with at the moment as Affordable Futures. I work for EPA most of my time to see if we can build a lot of these accounting within their way of doing business. I work with ExxonMobil a little bit for them to, what's happening, it's like they lose their installation in the North Slope of Alaska because the sea ice is melting, and they started suing the EPA that they're not regulating carbon emission.
No kidding. No kidding. Oh, you're kidding.
I'm going to make up some profit loss.
Extreme irony.
So weird things are happening.
Our savior is coming very strange for us.
So people come, Civilland is an organization in Germany who sends some people to Vermont to help. You know, it's like there's a lot happening, because, and also ExxonMobil, they came to me and said, it's not about making money, what about, where is it? Why are we doing this? Yeah, so but these things are happening, so that's good news. It's like, maybe it's not the people on the top and stuff, but it's like the people on the you know, who actually do all that. They're really questioning these things now. So I feel like ecosystem services is a very exciting time, and with my business I'm getting more work than I can do, which not too many people nowadays can say. So I think I'll leave it there.
We're here to talk about biodiversity loss and ecosystem services and the consequences of that loss for human societies. And I'm standing here representing a new center, a collection, a network of scientists, 70-odd scientists plus 400 graduate students across Quebec and 8 universities and 2 public institutions. And details don't really matter. What matters is that I believe in a vision that is about gathering scientific expertise together to work on this problem. The problem is too big for individuals to work alone. And scientists not only have to work together as multidisciplinary groups of economists or ecologists or whatever, we have to engage with the public, we have to engage with government, we have to engage with all the stakeholders to understand, to make sure that our knowledge flows in 2 directions and that we can move forward together. So allow me to present some results from the scientific community, some of which were generated by scientists in the center. If you're interested, there's the web page. It's being built right now. So, can everyone see if I stand here? Probably not. I'm not standing in a good place, but there's no one to stand. So, biodiversity is part of the biosphere. It's been there forever. All right, it's come and gone. It's fluctuated in its extent, its magnitude, and the numbers of species and the variation in genes and ecosystems has happened forever. The problem is right now is that in the last 50 to 100 years, we've seen massive acceleration in the erosion of that biodiversity, the loss of that biodiversity. And experts believe that it's 100 to 1,000 times the background rate, that rate we can estimate in a fossil record. And so we're seeing more and more quotes like the one you can see here from the Millennium Ecosystem Assessment, which says changes in biodiversity due to human activities were more rapid in the past 50 years than at any time in human history, and the drives of change show no evidence of declining over time. And that's the problem, is that we're not capable of reversing that trend. So we need to do something. We need to know better that system. And we do know the system. We can draw the boxes on the screen. We know how the bits go together. We know how now, for the first time, that human systems are the dominant driver in the Earth's biosphere. We're really changing the dynamics of biodiversity and the ecosystems which is part. And so on the far left, you can see those are the things that the changes in the environment that humans are affecting now. We all agree, even climate change. And then there's the bit in the box in the middle there, which is everything to do with the ecosystems and the biosphere. Right? The changes in biodiversity at the top, and we have the change in the way that ecosystems function at the bottom. And together those things influence, well, at least part of them, influence the change in ecosystem services, because ecosystem services are not everything. But they're a big part of the issue. And they plug in most naturally into the human system, right? Where we see that we're noticing for the first time that changes in human well-being are occurring because of changes in biodiversity and because of changes in ecosystem services. And a small part of that human well-being is the economic system. Obviously, it improves our well-being of many, many people, but it's not the whole story. But the question is, we didn't know. 15 years ago, I can stand here, 15 years ago, within my career, we didn't know whether biodiversity was causally involved in the function of ecosystems. Does it matter how much variability of life you have to the function of those ecosystems? It seems intuitive, it seems obvious, but we didn't know. No one had done the science. So we have now, 15 years and hundreds of studies later, a first answer to that question. Does biodiversity actually causally affect function? So here is the early hypothesis that was projected back in the dawn of time in the early 1990s. What you have on the horizontal axis, or the x-axis, is the amount of biodiversity in a system. It can be very high if it's on the right, or very low if it's on the left. And you have some measure of the health of that ecosystem, the functioning of that ecosystem. And you can see there are three lines, right? One is a straight descending line, that is that the ecosystem function declines proportionally with the amount of biodiversity there is in the ecosystem. Or you can have this descending catastrophic curve where small changes in biodiversity lead to huge changes in function. Or you can have something which is more slow, less radical, but ultimately ends up in a tipping point where everything collapses when you have very low levels of biodiversity. So, a show of hands, how many of you think it's the answer? I'm going to give you the answer now. I'm going to reveal the answer. How many of you think it's proportional loss? Nobody thought. 1, 2, proportional. Okay, how many think, 1, okay. How many thinks it's immediate catastrophe? 2, 3. How many thinks it's the rivet or redundancy hypothesis? Okay, you're right. You're streets ahead of the scientists. You're right. We know it's not immediate catastrophe, right? Because we're all here and there are 6 billion, 7 billion people on Earth. But there's a warning now. What we're seeing is that in the vast majority of cases, if we take 2 or 3 different ecosystem functions, we'll call them services later, whether it's biomass production on the left, or nutrient uptake in the middle, or decomposition in the soils, what you'll notice is that between 60 and 80% of the studies, we see this change, right? That there is a causal relationship between biodiversity and ecosystem function. And that is an incredibly important thing to know, right? And we can spend much more time trying to figure out the details.